You want the database to adapt to what you're doing with your data. But the part where I found that to be really problematic is when things become non-predictable, right? So that's where that, level of introspection becomes so important, because you need to know what the database did. I worry that, if we're in this future where everybody uses a cloud database that they don't have any actual true root access to, or true understanding either, right? They can't look at the source, that we're actually losing that ability to really dive into the details when we need to.
Hello, I'm Martin Thwaites.
I'm Charity Majors.
And I'm Jessica Kerr.
And you're listening to Observability Cast, or o11ycast for short. A monthly series where we talk about how we can make production systems more observable, more reliable, and easy to maintain.
o11ycast is brought to you by Heavybit, a program dedicated to helping startups bring their developer products to market. For more information, visit heavybit.com.
If you're interested in being a guest on this show, or if you have a specific topic you'd like us to dive into, you can reach us on Twitter at o11ycast. That's at o11ycast.
Yeah, I think that's, a very typical frustrating developer situation. As you said, typically I'm just thinking about my app, right? I have all the activity in my app. I have my functions. I have my API calls. But then really where the application monitoring usually stops is at the point where you have, for example, a SQL query that goes to the database. Unfortunately, a lot of times then at that point, application developers are like, well, I don't know what's going on, throw hands up in the air and pass it on to, for example, infrastructure team, DevOps person, or DBA if they have it. And I think that separation ultimately is not healthy, right? I think that compartmentalization, that anything that's, a database call gets passed to somebody else is not, helpful for us to actually have a kind of complete understanding of application performance ultimately. And so the reason that I personally care about OpenTelemetry and observability in general from an application perspective is because if you think about this, let's think about slow experiences ultimately, right? What we're trying to improve is that somebody is sitting there waiting for your web page to load, and we want to know what's going on behind the scenes. Why is it actually slow? Is it slow because you wrote inefficient code? Is it slow because the database chose a bad query plan? Is it slow because somebody forgot to add an index? All these are, possibilities. But if we ignore the database, we kind of, only have half the picture.
Yeah, I think you're right. And this is something that's always bugged me too, is the way that this sort of I can't tell if developers have been trained into this feeling of helplessness or if they've just been shocked too many times by the database and that it's scary. But it's like with your code, you're kind of more or less in control. But with data, you have the code that you're running and you don't know what you're running it on necessarily. And that select star could return instantly, or it could take a week based on the data that it's scanning and, the order that it was inserted and whoever built an index. Or sometimes you wake up overnight and maybe there was a security thing going on overnight and suddenly the data is no longer like you remember it being, and your entire performance profile can change. But I think that separation is not healthy, because in the same way that your code is nothing without production, and you have to care about production. Your code is nothing without the data either.
Yeah.
These are integrated. There's room for specialization, of course, but you can't hope to understand and debug your app without a reasonable understanding of the trips and traps of data and how it affects your performance and how you need to modify your code in order to handle it.
Right.
This feels like a good time for you maybe to introduce yourself.
Sure. I'm Lukas Fittl. I'm the founder of pganalyze. I'm an engineer by trade. I started using Postgres 15 years ago. Postgres is my main database of choice. I run a small company called pganalyze. We offer performance optimization, performance monitoring, and observability for Postgres. And, we're happy to be here and talk about observability and how, you can integrate application perspective as well as database perspective together.
So what does it look like? What does it look like when you can see out of the application and into the database in your same trace?
So I think the hard part is that even with pganalyze today, I'll be honest with you, that solution is still kind of not, as nice as I would like it to be. So this is not me pushing our product. Actually, this is me pushing Google's product. So Google actually tried something here, which I think is interesting. It's unfortunately not a great user experience, but it is, I think, interesting. So what they did with Cloud SQL is they actually offered an integrated tracing kind of perspective with, I think, Stackdriver and Cloud SQL. And so they actually have a way to combine those and kind of link the traces together. And so what, I'd love to talk a little more about also is they actually created a project to support that. So they created a project called Sqlcommenter, and Sqlcommenter is now part of OpenTelemetry. But the idea is that you essentially annotate queries in a way that you can look at it both, kind of at the database side, you can see what's the query plan for a particular trace. There's still kind of that step though, where it's not really seamless, right? So if you think of a trace and with the different spans, the way it still works is that you're making a jump from the application perspective to database perspective. So it's more about linking things together versus necessarily...
Oh, okay. So it's a link between traces?
That's right. This is a link between traces, and more specifically, it's a link between the execution plan of the database. So what they implemented and what we also have in pganalyze is essentially a way to say, here's an execution plan for that particular part of a trace, right? So if you see that query with that span or with that trace ID, then you're actually able to say, what's the execution plan on a database side for that flow experience, essentially.
Okay. So currently you still have to go to another tool.
That's right.
But you're able to get to the right place in that tool from your trace.
That's correct. Yes, exactly. So the big value here is being able to drill down, right? So the part where I think today most observability tools, if you look at this from the application side, the SQL query is where it stops, right? And the text of the SQL query, but you don't know anything else. You know how long it took, like from the application side, right, including network round trip, but you don't know whether it used an index, whether it, did something like what it did on the database side. And so that's really where I think this combination is so important.
Yeah, the pattern of where, anytime you're jumping between application and database, you might get a completely different answer about what's happening if you're inspecting it from the database logs than you would get if you're inspecting it from the side of the application. The application might go, that took 11 seconds. And the database might be like, what? We ran it in 0.3 seconds. Like, what the hell? So yeah, I think that this has always been an interesting sort of like gap. And I remember at Parse with MongoDB, we were very cutting edge, like MongoDB users. And we did some janky ass shit to get what we needed out of MongoDB. We turned on like full query logging for all queries for all MongoDB clusters. And then we did like some intelligent sampling, which would dump out things like number of row scans and indexes used and all this stuff. And then we would dump that into, Scuba, which is like a precursor of Honeycomb. And it wasn't connected to the application stuff, but like that was the only way that you could go in and see like what query plan is it using and why does it jump around and use different query plans depending on which shard it picks and giving it nudges and all these things. Yeah. So you're saying that this basically integrates that so that in one trace, you can see both sides of that interaction.
That's ultimately the idea, exactly. The part where it's challenging, and I think part of the reason why we haven't really seen a fully integrated solution yet where, let's imagine a Honeycomb that has, the database side just integrated and shown directly in Honeycomb, for example, or, let's say Datadog or New Relic, right? Like they all don't do this integrated view. And the reason that doesn't really exist today is because on the database side, you usually don't have exact measurements. Like that level of analysis doesn't really work the same way. So what we usually recommend people do is to enable like query logging, as you mentioned, right? You could, of course, turn everything on. That's not good for performance reasons.
That's the thing. That's the problem. You can't do this for performance reasons. You can't capture that level of telemetry without basically TCP flooding your entire node.
Exactly. And so what we usually recommend people do in Postgres, which we primarily work with, there's an extension called auto-explain, and that essentially logs execution plans, but only either if it's like matches the sample rate, so that you can say, do 1% of all queries, log that to the log, or do something like everything that's slower than a certain threshold. And so our recommendation is essentially do that for your database, right? So have some way of like logging the slow statements is usually what we recommend with the execution plan. And so that way that is safe enough. Now, the problem is where it gets expensive is the timing information. So if you think of an execution plan, oftentimes execution plans have, these plan nodes. And if you want to know, like if you imagine how do we represent an execution plan in a trace, ideally each of these plan nodes would be part of the trace, right? So it would be query and then it says, index scan took 5 milliseconds, hash join took this much milliseconds, right? And the problem is that is actually expensive for a database to do. So in Postgres, for example, we always recommend people to turn off that timing information because it's expensive to do these get time of day calls essentially very frequently. And that's where it gets challenging, right?
Yeah.
Oh, okay. So specifically, the what time is it is very expensive?
That's right.
What time of day is just known to be very expensive.
Yeah, it's just like asking the operating system what time it is expensive. And so there's various tricks how you can make that less expensive, but it's...
Yeah, because for complicated reasons, but like it's just like one of the slowest things a kernel can do because it has to be precise.
Right.
Interesting. I want to get some definitions in here because we've been throwing around a bunch of database terms. Let's tell everybody what a query plan is.
Sure. So when you tell the database, select star from table, ultimately the job the database is doing for you is figuring out how to get that data, right? And so in most databases, you call that part that's figuring out the planner. And so the planner, or in Postgres, sometimes the optimizer, essentially looks at that statement, like the parse tree, and says, you're looking at this table and you want these columns and you're filtering by this information. So the best way for me as a database to give you this data is to do an index scan, for example. And database then decides, do the index scan on this particular index. Or if there's two tables involved, make a join between those two tables.
You can see how this becomes really relevant when you've got really complex queries, right? When you're selecting from, say, a bunch of different columns or doing joins or whatever, because you've got fucking indexes all over the place. You've got all these different data types, right? And using the parse tree, like there are ways that if you do certain things in certain orders, it could be a lot cheaper. And if you do it, I don't know if this is typical, but I remember when at MongoDB, the way it would actually, so it would cache the query plans. The way it would do it is 1 out of every 10,000 times a query gets run, it would run all of the possible plans for that query, and it would pick the shortest one, and it would cache that and be like, always use this plan until, it refreshes the cache. And the reason you have to refresh the cache is because sometimes the shape of the data will change, and what was fast will no longer be the fastest way anymore.
Right.
When you've got like compound indexes, say you've got a data type that used to be just, a couple of integers, and then all of a sudden it's a bunch of strings or something. Well, then your query plan may need to change in order to be efficient.
And the part where that behavior is generally good, right? You want the database to adapt to what you're doing with your data. But the part where I found that to be really problematic is when plans are in Postgres, at least, they're very particular to the values passed in, right? So if you search for something really frequent, it will often use a different index, a different join strategy than if you search for something really infrequent. And so the problem is when things become non-predictable, right? So sometimes your queries are fast and sometimes they're slow because the database decides to use a certain plan that's actually not the best plan. And so that's where that, level of introspection becomes so important because you need to know what the database did and why, ideally.
But I would kind of argue, though, that these should not be problems that your average developer is running into every day.
But when you run into them, it's really important to know, I just did a full table scan.
So the missing index case in particular, right? So if there's really no index at all, that's, I think, a case that the regular developer probably will run into.
Yeah.
But maybe the plan falling over, that's more of an edge case.
Yeah, the plan stuff, it should be magical, right? That the point is the database should be able to pretty much do this the right way most of the time. I guess I'm just wondering, proportionally, at your normal, SaaS, startup, developers shouldn't need to spend much time thinking about this at all because it should mostly work most of the time. Right. Whereas the threshold of complexity or size that you find that teams start to run into this stuff regularly enough that it's worth expending a significant amount of resources on capturing this data.
So, what we found is that if you get larger companies, right, where there's multiple application teams, usually what starts to emerge is some kind of central data platform team or data engineering team, whatever you want to call it, right?
Or a DBA.
Well, they don't really like calling themselves DBA these days,
Oh, is that? I was going to ask why nobody has a DBA anymore.
It's not cool anymore.
Administration is out of fashion.
Exactly. Yeah, system administrators are gone. Database administrators are gone.
Okay. So what are they called now?
Well, probably data platform engineers.
Platform
or
engineers.
application, sometimes application DBAs. So there's also, just adding application in front of the DBA to make it seem like they're more on the application side, not just the, sitting in their castle, accepting index changes and stuff like that.
So you're saying basically around the time that a company gets large enough to have a dedicated data platform team.
Yeah. And I think what we've seen a lot is that these teams often struggle because ultimately they get past all the problems, but then the ones, sometimes creating the problems, so to say, is the people introducing new features, right? So the application team works on a new feature, releases it into production, and then they realize, they forgot the index, or maybe they didn't benchmark it well enough, right? And then database side falls over, and then suddenly the data platform team gets this surprising, oh my God, we must all hands on deck, right?
And the whole point of platform teams is not supposed to be like, okay, pass us your problems.
Right.
It's okay, we're creating solutions so that you can self-serve and explain understand your own problem. So this would mesh very well with that philosophy.
That's right. And I think, so beyond just open telemetry and observability, one of the other things that we've done in that space to kind of support application teams better is to give them like ways to get index recommendations. So we're not the first to do this, right? Like SQL Server, for example, has had this for a long time. But one thing that we found is that even just getting a starting point for saying, hey, you're doing all these queries and you're not, you don't have any supporting index for the where clause you're passing in there. Even that, and telling that to an application team in a very straightforward way, that's very big time saver, right? Because then that data platform team enables the application engineers versus gets, looped in all the time for all changes.
Totally.
So with the right tooling, can a small company postpone having a data platform engineer for longer?
Probably, hopefully.
Charity is nodding.
I think what's just challenging is I think that skill set is still valuable, right? So even if you have the right tools, you still want somebody thinking about these things, but maybe it's a backend engineer who has, a tendency towards like being interested in databases, right? And so that person becomes 1/4 of a data platform engineer until you really have the need for a full team or a full person.
Yeah.
Because if you can see what's going on, you know when you need to take action.
Right.
Yeah, I think the way I would characterize it is less maybe that you could put off needing to have a data platform team, and more that once you need one, you can leverage a much smaller number of people for a much longer time. Like instead of having to kind of grow proportionally with your application engineering teams, because the more people you have, the more problems you're getting sent, right? You could have a very small, limber team that knows which problems that they need to help developers solve for themselves. And that's so much more scalable, right?
Right.
And I kind of love that we're now in this post zero interest rate world where we now have to think about engineering efficiency again. I think this is fantastic because so many of our problems in the past, we would just solve them by throwing bodies at them. And we said that we weren't, but we still did, right? And ultimately, that leans into creating busy work for people and not giving people to actually solve the problems using automation, which frees them up to solve better problems. And I really kind of love that, like Adam Jacob, one of my personal heroes, he was at Chef and, they were going around, evangelizing automation into all of these companies that are, they've got system administrators still, right? And the anxiety palpable, because it's their job, it's how they put food on the table. And Adam would always say to them, look, everyone here, your jobs are safe, right? The point now is, how do we make it so that the same number of people can do more and more and more, so that you can do more and more and more with your time, instead of having to scale linearly with the number of customers or the size of your data centers, right? This comes up over and over again. How do we scale people, not linearly, but so that people can be more and more and more powerful and do more and more things with fewer of them?
Yeah, and I think we've seen that exact pattern, in the database world, in the Postgres world specifically, where, that data platform team or the single database administrator, if they call themselves that, just is busy fixing slow queries, right?
Yeah.
That's their day in, day out.
That's all they do.
Engineer passes, says, hey, I need help on this. Next engineer says, I need help on this, right? And they keep just looking at query plans, doing all this manual work.
And they're so busy doing that.
Exactly.
And then you can hire more and more people to just fix queries all the time. And that's basically the job, right?
Right, exactly.
Build indexes, fix queries. Build indexes, fix queries.
Or they're looking at the databases logs and they see these slow queries and they have to chase down the developers and tell them to stop doing it that way.
But they're so busy that it's not like they have time to do other things, right? Because you always hire just enough, and the whole point of this is to get ahead of that,
right,
and to start, building tools and free up time for these people.
Right.
Which is why you should really want your database teams to be using as many of the same tools, same languages, same patterns, same, product development as your other engineers. The less of the silo it feels like, the better off everyone will be.
Yeah, fully agree.
What does open telemetry have to do with databases these days?
Well, unfortunately, just a little bit these days. I think, part of why I'm interested in talking about it is because I think it should have more to do with each other. I think where it's challenging is, database people are not open telemetry people usually. Like we don't talk enough with each other.
Yeah.
Like in the Postgres world, how most people interact with OpenTelemetry is they would have, Postgres exporter that exports like some basic high level metrics, right?
Yeah.
And then that's how they send that like information. And these days that's OpenTelemetry. It used to, be whatever custom format it used to be called. But that's usually where OpenTelemetry ends. And then really the other side of that coin is the Sqlcommenter story, which is, it's really like a niche project that, Google contributed to OpenTelemetry. But I think it starts telling the interesting part of the story, right? Which, as mentioned earlier, is how do we get the trace like information together, right?
How does it get the trace information into the database tooling?
So the way it works with Sqlcommenter is essentially it's an additional library that you add to your application. So the same way that you would add, an auto instrumentation with OpenTelemetry, you would essentially add the Sqlcommenter library as well. And there's bindings for Ruby, Python, Java, popular frameworks essentially. And what it does is it automatically adds a comment to each query that gets executed by the ORM or by the database driver. And that comment can include a couple of things, but most importantly, in the context of tracing, it will include the trace ID and sometimes the span as well for, where in the application you're at, essentially. What happens then is, imagine on the database side, you have a slow query, and the slow query gets logged to the database log. Then that slow query will have that trace ID and that span ID right next to it, right? Like next to that slow invocation. And so that way you have that connection when you look at the database side of the house, where you get, more details, right? The query plan and all the other stuff. Then you also know which trace that belongs to. And so that way you can combine it.
So could we take that database log and like export that as a span?
We could potentially, yes. Yeah, I think that's ultimately where, one of the things that we're looking at pganalyze is to, optionally allow that to happen, right? So essentially, because what we do today is we do a lot of log parsing, right? So we look at these error logs and we're like, hey, this is log event such and such, and here's the query plan and it's a JSON, blah, blah. And so we already get that data. And so one of the things we're exploring is how can we send that back into, another system. Let's say Honeycomb, for example, right?
Yeah.
And if you saw some information there, then you could actually, have a link again between those two systems. And in a sense, OpenTelemetry and open tracing and whatever it used to be called, like the idea is that different services can send to the same trace. So you should be able to just add additional spans that give more context.
And could provide a link on the new span. You could provide a link directly into pganalyze tool.
For example, yeah, exactly.
And that would be a place where your data platform engineers and your developers could communicate.
Right. Yeah, exactly. And then they have a shared thing to talk about also, right? Because oftentimes that's super helpful if you're looking at the same thing, you're talking about the same thing. You're not just sending around huge text files or something.
Yes. It's not my logs versus your logs.
Our logs.
It's our traces.
Well, or a screen share of somebody.
One thing I wonder about these days is new developers. When I was young, I learned SQL really early, and I had a friend, made friends with a DBA in the company that I was working, and I got a book on SQL, and he showed me, what was the tool in Oracle? Precise. It was Precise. And in there, he could show me the query plans. And then he gave me access to be able to do explain plan and ask the database, hey, if I give you this query, how are you going to run it?
Super user.
But this was normal. This was what I needed to do my job as a developer back then.
Right.
It's heady. It's exciting.
It is. Databases are actually really cool.
They are.
They are.
I don't feel like most devs these days get that opportunity, even to play around at SQL prompts. What's up with that?
Well, ORMs, right?
Right.
People don't write SQL anymore. People write function calls.
ORMs ruin everything.
Yes.
Well, they do, but it's a reality, right?
Yeah.
If you ask any person working on Postgres directly, they're like, how do our users, right, the people who use Postgres actually write their queries? Of course, in SQL, right? There's this huge disconnect that, most people that use databases like Postgres, they don't write SQL. They write ORM.
They really don't write SQL?
Yeah.
No.
Yeah. And that gets to if the DBA comes to you with, look at this terrible SQL, you're like, oh, I don't know where that came from.
Yeah.
And that's where tracing is really important, because there's auto instrumentation for your ORM, right, that you can see what you did in code to cause that query to come out. And then you you need the ORM wrestler, and those people are rare.
Right.
It is a little unfortunate, though, because it's so much easier to spot potential problems in your query if you're looking at it in SQL than you are in ORM.
True.
Like, it's just, at least for me, it's like code just looks like code. But in SQL, you're like, that doesn't look smart. Oh, look at that left join. That's probably not going to end well.
And that's a plus that you get from tracing is at least you can see the SQL that's generated.
Yeah.
And also you can see the N+1 SQLs that were generated.
Yep. Definitely still a problem.
Yeah.
The one thing I would add, to be complete in the picture, I do think there's a bit of a trend actually back towards SQL, right? And that's, for example, in Go, there's a library called SQLC. And so what SQLC does, it has you write SQL in your Go code, and then it analyzes that at, I think, compile time, and then builds essentially the type information, like extracts type information from that query and auto-generates a binding of sorts to that query. And so you're always writing SQL, but you essentially get typed SQL in your code. And that's really neat because I think it ultimately, gets us back to the SQL writing, right? Which I think is a good thing probably. But it abstracts it better so that the application can use it more effectively.
And in Java, it's called Jooq.
That's right. Mm-hmm.
Jooq, which I find ironic because ORMs are for object-oriented code, and Jooq has OO in the name, and it's actually not an ORM.
Yes.
So the OO in it confuses me.
But it's good. If I was using Java, I would definitely look at Jooq. I'm a huge fan of, the blog posts that the author publishes regularly. So definitely a good one to look at.
Great. So SQL is coming back, but also we're blurring the lines between developer and data platform engineer. We actually don't have that at Honeycomb, and it worries me.
We have a team of Ian, Doug, and Hazel.
Well, we write our own database.
That's our data platform team.
Right. So our own database we understand really well, and it has a lot of tracing.
It has a lot of tracing. I mean, this is I feel like the other thing about databases that is why they're so opaque to software engineers is because you can't really instrument them, right? They have logs and stuff. Yep. But if you want to, it sits in the, you've got the infrastructure code, the stuff that you have to write in order to get the stuff that you want to write. And then you've got your crown jewel code, right? And databases are this really important, really complicated piece of software that you should not be shipping this to or instrumenting it to see what's happening, right? And so I feel like that's contributed to some of the priesthood aspects of it over the years. It's just, there's been so much knowledge that you can't instrument it, you can't see it, it becomes just like it in your gut or you don't because you've broken it so many times and you've learned the hard way or you haven't.
Right.
They're also really mature.
Yeah, I mean, Postgres is really old. It turned 27 years, I think, this year.
Wow. Yeah, databases are magic for reasons because there's many, many, many layers of expertise built into that database.
Yes and no. I mean, there are some old stable databases, data losses, not if, it's when. But there's also a lot of, the DBRE book is way overdue for an update because, we wrote it, 7?
What's DBRE?
Database Reliability Engineering, the O'Reilly book.
It's a good book.
We wrote it 7 years ago, and there's nothing about cloud databases in it. There's nothing about, your columnar stores, your even the Google database or Amazon's Aurora. There's nothing about how to run them.
One thing I worry about with the cloud databases and all the managed services, is that you're losing even more introspection abilities, right? For example, there have been multiple people recently doing work to do eBPF tracing with Postgres. So to essentially, not just look at Postgres from let's run a stats query to see which queries have executed, but just use eBPF to essentially say, which functions are being called. And that actually is very valuable because you can annotate things and trace things that otherwise, you don't have data on. And I worry that, if we're in this future where everybody uses a cloud database that they don't have any actual true root access to or true understanding either, right? They can't look at the source, that we're actually losing that ability to really dive into the details when we need to.
I feel like this kind of comes back to just the principle of if it's your core differentiator as a company, you need to know it intimately. For most companies, they don't really need to push their databases that hard. They can just kill it with money, right? Provision a little more, be a little sloppy, whatever,
Right.
Yeah, and the trick is don't kill it. The trick is just if you need to push it harder, split it up into 2 databases or something. Right. Stay within the parameters.
Yeah, exactly. It's incredibly easy. But once it becomes your core differentiator, or when you reach, a certain inflection point, threshold as a company, then you're going to have to bring it in-house because you just are. And yeah, it's going to be a specialty.
Hopefully then you're big enough.
Then you're big enough, yeah.
But I think that's where it's also important early on to choose something that has longevity, right? Like if you choose, either you choose a startup that creates their own database technology and then they go out of business, right? Then suddenly your database doesn't exist anymore. That's the one risk.
Well, yeah, that's why we don't let anyone else run our database. We run our database.
Right. Yeah, exactly. If you have that.
It's very much about right-sizing your risk. Like at Parse, we made a lot of risky and interesting choices. Like we launched with MongoDB, which is in 1.0, one lock per replica set at the time. We were running Ruby on Rails, and some of those things came back to bite us. We grew up with MongoDB pretty well, but it was the Ruby on Rails one that really kind of hurt us because, fixed pool of unicorn workers, no real threading support. And once we had, hundreds of thousands of mobile apps and a whole bunch of backing stores, as soon as anything got slow, everything went down. So we had to rewrite it, the entire thing in Golang. But you almost never go out of business as a startup because of your technology.
Yeah.
If they're good enough to keep you alive long enough to survive, they were the right decisions.
I'm curious, would you these days, if you did that again and on a database side, would you choose MongoDB again, after all these lessons learned?
Hell no. Absolutely did not. It depends on for what, right? It's great for some things. Anything super high performance, it's not. I would argue that what they really got right was, ironically, the JavaScript interface instead of making you learn another language, and the administration aspects, the replication, the leader stuff, the way it automatically failed over whenever the primary, how is it that MySQL is still in this state where you can't? It's absurd.
The sad truth is Postgres is sometimes even worse on that side, right? I think that's the most common criticism that Postgres still receives these days. And I think a lot of it justified is that the administration and that tooling, right, for doing complex replication setups, it's just still not there in core. You can go purchase it, but it's not part of the core project essentially.
Yeah. Anyway, would I choose it? We did not want to write a database. We looked at everything out there and came close to using Druid, but it was written in Java and we would have had to rewrite a third of it anyway just to get flexible schemas. And we were like, honestly, if we were to start Honeycomb today, I bet we would use something like ClickHouse.
Yep.
But I think ultimately that would have been very limiting for us because I think that, there are going to be so many Me Too things, which is just they're built on top of ClickHouse. They have a pretty good UI, and they're they get you 70% of the way to something Honeycomb does. But then you are limited by ClickHouse's built-ins, and you can't do a lot of the things that we do that are just kind of near miraculous for observability.
Right. It turns out that because our data store is our core differentiator, it's a big part of it anyway.
Yeah.
We actually get a lot of benefits of having that in-house. All those maintenance costs of maintaining it ourselves are a win for us because we also control change.
Yeah.
I'm curious. This is kind of a tangent, but I'm curious. You mentioned earlier you have good instrumentation for your own internal data store. How does it actually look like?
Heavily sampled.
Heavily sampled and traced. Ian Wilkes started writing the database the first month that we started in Honeycomb. And so interestingly, and I know we're almost out of time, but the database started out looking like a fairly traditional columnar store. And then at some point we serverlessed our database. And we actually shipped the query planner and the query builder and everything to AWS Lambda jobs, which if you think about it, we would never have been able to run Honeycomb in any kind of cost efficient way if we had to provision SSDs, because all of these resources would sit there idle almost all the time, except for when somebody issues a query and then it needs to be super fast. You've got all these wasted resources. And so moving a lot of that to Lambda jobs and moving a lot of the storage to S3 and then just parallelizing those merges in the Lambda job was also an Ian Wilkes thing. But we've actually given some Jess actually gave a talk about this at Strange Loop a year or two ago.
Yeah, because Ian didn't want to come, so I got to do it.
I mean, one thing it sounds to me like from what you're describing, right? One thing that you all are doing right at Honeycomb is to treat the database just like any other piece of software, right? I think that's part of the issue oftentimes is ultimately database is just software, but we're treating it as if it's something separate. And what if we just think of database as a function call, right? Like it's just another file in your source code, essentially. I think that would be much healthier.
You still have to program it with indexes.
Exactly. Yeah, you still do, right? Like you still pass some arguments,
hints
right?
Sometimes.
Yeah.
Well, thank you, Lukas. This was really interesting.
Of course.
Where can people find you?
Sure. So these days I'm more on Mastodon. You can find me on the Hashiderm server as Lukas, and then I'm still on Twitter /X as well, although I'll probably leave soon. And then pganalyze you can learn more about on pganalyze.com, or we also do a weekly 5 minutes of Postgres episodes, which are essentially short YouTube videos where we talk about Postgres. So if you're interested in Postgres specifically, definitely look at our YouTube channel for pganalyze.
Well, this has been a fun little walk down memory lane for me.
Yeah, thank you for making it. That's great.
Bye.
See ya.
That's all we have time for today. If you're interested in being a guest on this show, or if you would like to suggest a topic, find us on Twitter at o11ycast. That's o11ycast. o11ycast is brought to you by Heavybit, the leading investor in developer-first startups. To learn more about Heavybit, visit heavybit.com.